All right, welcome in. Zach, you got first. Brian, hey, almost first. I'm sure things are going okay on YouTube. Let me get my chat ready because you literally can't do that until you're live, unfortunately. So I find a solution for that. Come on, give me the URL. There's that. There we go. Okay, let's go look for some questions. Matrix. Ooh. Okay. This is one of the few things with matrices that I do know how to do. So let's see. Oh god, it's an annoying thing to do though. Let's even spot the error. Oh, we got a Rubik's Cube already? Alright. I like it. Did I bookmark this? I did. First of the stream? Yeah. Okay. Let's do some scramble. Okay. Inspect. Ooh. This one has a good bit of it done for me. Okay. Ugh. Oh god. Ugh. My movement is horrible. Oh no, it's this one. Frickin' V-perm. Ugh, that could have been a lot better. Oh well. Wish. That is Texas Hold'em Poker, as far as I know. Thank you for the Rubik's Cube, Zach. Poker. Is that what? Okay, Wish. I respect it. Oh my god. We had Sodom stream the same Rubik's Cube twice? I bet it's really low. How many permutations are there of a Rubik's Cube? That many? 43 quintillion? I guess... I didn't think there'd be that many. At least 7? Yeah. A little less than the square of Earth's population. I didn't think, like, there'd be that many, because, like, you know, this corner is always, like, the same colors, so I thought you'd have a lot of, like, repeats or something. The more you know. Yeah, some of the things true with, like, a deck of cards. Like, every time you shuffle a deck of cards, it's more likely than not that that's, like, the first time in the universe that particular order of cards has ever happened. As far as I know. I guess it's 52 factorial, which is a huge number. Okay, let's see if we can spot the error in this person's work. It's really annoying to like spot mistakes in this. Let's make sure they copied things down right. Oh, they don't show the original problem. They're just solving the system of equations, Wish. You're doing the same things? Oh, cool. Yeah. Hey, Jed. All right, so let's see if they set up the augmented matrix right. Looks good to me. So they take 4 times R2 and they subtract 3 times R3. Wait. But no, the next step, R2 stays the same. So what are they actually doing? I guess they're subtracting something from R3. Okay. Oh god, I hate the way that they've noted this. It's not very clear to me, but I think this is backwards. They're taking 3 times R3 and they're subtracting R2. That's how they get the 0 here. And then they do 3 times 6 is 18 minus negative 4 times 7. 18 plus 28. 46. And they have 46 there. Okay. And then they take minus 3 times minus 1 is positive 3. Well, no, this is where we're getting the signs mixed up. It's 3 times negative 1 is negative 3. Minus 4 times 7 is negative 31 as they got. Okay, good. Code a step-by-step matrix manipulator. Oh my god, Brian, that would be like a godsend. Because these are really tedious to check. I should wait. Well, I should see the actual verify the results. I don't think I'm doing this properly. Okay. Cosmonal, any string theory fans in chat? Oh gosh. I don't know about string theory specifically. I know that Storm 2 Payne is studying physics in general. I don't know if they're specifically doing string theory though. Sheldon Cooper fan. All right, and then the last slot we do 3 times 7 is 21. Oh, they even have the little numbers. That's what those little like subscripts are. Okay, so they do 21 minus 32. Shouldn't that be 11? They get a 21 there. Or it should be negative 11. Okay, maybe that's the mistake right there. So just like them putting R2 first is really throwing me off. You're doing, what would we say, 21 minus 32? You wrote 4R2 minus 3R sub 3, but I think you were actually doing 3R sub 3 minus 4R sub 2. Right, look, it's good. So now they're writing this next one is backwards too. They said R sub 2 minus 3 R sub 1, but they're, well, actually no, that one's right. Okay, never mind. They're taking R sub 2 as it is, and they're subtracting 3 times R sub 1. So yeah, 3 minus 1 times 3 is 0. Negative 7 minus 3 times negative 3 is negative 7 plus 9 is 2. Okay, good. Matrix manipulator? All right. So, sounds good, Brian. I think I already spotted their first step. I'm just trying to see if there's like... Actually, I should just post this, because I think they already made the error here. Donna's doing linear algebra. I could feel your presence, Penn Center, so I had to look at a linear algebra problem. I think I already spotted the mistake, though. 7-stream watch streak? Hell yeah. Thank you. I was lurking on your guys' race last night as well. I'm not experienced enough to know like who's in the lead or not, but it's been fun to like watch. Just because all three of you are doing like runs in a different way too, so it's cool to see the different like strategies or like puzzling through it. Danny's good to go now. Oh yeah, I saw that. See, he got the hammer from the Zora place. And yeah, I saw like for whatever reason the Zora King like there's like a super long cutscene where he just like moves slightly in his bench and it takes like forever. I don't know what was up with that, but it was funny to see. You're hoping you did not find it. Okay, but I think they already made a mistake on the first step here, so maybe I should just post that and not check all the rest of their work because there's already a mistake here, so the rest of the numbers are kind of thrown off. Okay. Post that. Look for a new one. No more linear algebra, please. There's been a lot of these, like, just flipping a coin quote questions. I don't mind it because I know how to answer them, but it's kind of funny to see how many there've been. 2v5? What is 2v5? Is that supposed to be choose? Are they saying 5 choose 2? Ever plan on playing the new COD? Probably not, Frylock. Aren't CODs up to like $70 now or something? And they release still one every single year? Like, I like COD, but that's kind of a high... We're basically paying a subscription without actually paying one. In old COD, I might do at some point just for some nostalgia, but hey, Enigma. If you toss 5 air coins, how many ways can you attain at least one head? Is that just 5 choose 1? Or 1 choose 5? I already forget what order. I always forget what order you're supposed to say it in, but will that just be 5 ways? I don't know what this math is. 5 fair coins. Oh wait, at least one. This is weird because it's like it's more like counting than I guess doing the actual probability part of it. I'm still wondering what the V stuff is. Okay, let's see if I can get 31 here. I assume you do 5 choose 1, plus 5 choose 2, plus 5 choose 3, plus 5 choose 4, plus 5 choose 5. Is there an easier trick like you do, not, I guess you can't do 1 minus 5 choose 0. Well, 5 choose 0 is, I guess. I'll just see what this comes out to. I'm just gonna try random things, because that's all I know how to do when it comes to counting. I equals 1 to 5. And where is choose? Choose, choose, choose. It's not here. Really? I know for a fact that there's a choose thing somewhere. You can't hide it from me, Wolfram. I know your secrets. What is this? Oh, piecewise function. Never even noticed that before. You can do Fourier in Laplace transforms? Oh my god, I did never even notice those. Okay, I can't find Wolfram's choose thing for some reason. Just say 5ci and see it if Wolfram interprets it, right? Nope. It's the cosine integral? Yeah, that's definitely what I wanted. If I did 5 space I in parentheses. Nope. All right, I'm going to a different question. I'm not good at counting. Oh god, chi-square? I don't remember chi-square that well. Let's see if we can figure it out, though. Oh, if you type it out literally? Okay. Bonjour, mais... Oh, I'm not even going to try to pronounce that. It sounds like you're saying good luck on your journey in math of some kind, so thank you. Oh, wait, I do get 31. All right. Thank you, Jed. Encore to you too, Hypatia, I guess. The day of mathematical inquiries. Ah, okay. At least two tails. Okay, so let's do the same experiment with their 10 coin example. So this time we're going to go from 2 to 10 of 10 choose I. 10, 13. Okay. So bored. What am I trying to say right now? I have, but at least dot 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 doesn't confuse them. My specialty. There may be a more convenient way to calculate it. But as I understand it, the question is basically asking how many ways are there to arrange one heads out of 5 coins plus 2 heads out of 5 coins, etc. Same method. I'll leave it at that. Thanks for that shout out, Jed. Or for calling that out. Okay, so this one, they said it might have something to do with chi-square. I don't remember chi-square very well in stats, but let's see if we can read the question and see if we agree. Oh yeah, if you're talking about probabilities of sample standard deviations, then I think it's almost certainly chi-square. Let's see if I can... Probability of sample standard deviation. So I think chi-square use it for making guesses about standard deviation, rather than like z and t are for guesses about the mean. These are not what I want. The mean is degrees of freedom? Man, I really don't remember chi-square. It's a really short, like, explanation too. Let's look for a different one. University of Saskatchewan. Saskatchewan's never steered me wrong, but before. They also never steered me in general, but let's see. What are they trying to probability? Oh, wait. Maybe I'm misinterpreting the question. Large studios found the summer electricity bills for single-family homes followed a normal distribution with standard deviation of $100. Wait, so we're sampling from a distribution here? We want the... What? I was kind of fixed on their hint with saying it's a chi-square, but it might not actually be chi-square. Do you have to maybe rearrange the probability? Yeah, Pen, it's probably that. Does that give us an actual probability though? I need to remember, like, I guess we get the critical Z and maybe get a probability from that? Or not the critical Z, but just what the Z is. So yeah, the mean is the same, and then sigma sub x bar is equal to sigma over root n. So we do 100 over root 25 is our sigma sub x, but that we need a... This is a little bit of a backwards way that I find the z-score from your new distribution. The sample standard deviation is less than $75. Does that apply to this? I'm getting confused on the wording of A and B here because usually, like, that's what we do to get the mean. But they're asking about standard deviation. I don't think I've done a question exactly like this before. I think it is using the same idea, the sampling from a normal distribution, but we need some other rearrangement of the formula. I think. Hmm. No, No worries at all, Pen Center. I'm not familiar with it either. I wonder if I can figure it out though. What do I could just Google the exact question, I guess. In a large city, it was found. I should have looked at more of the text. Got some electricity bills. Single-family homes followed a normal distribution. Standard deviation, $100. Oh yeah, all these things are gonna make you pay. Actually, Weebly. I haven't thought about Weebly in such a long time. Oh hey, I think this is the exact question here. Hey Dan, greetings from your brother's couch? Oh, that's cool. It is the same formula, looks like. Well, have fun at your brother's couch. I guess I was about to say house, but you know. Maybe the couch is just outside. You know? I shouldn't make assumptions. And large city is found... But yeah, okay, this is the exact same question. Being couchy! Oh, is this a chi-square? That's a formula for a chi-square, I think. Oh. Chi-square formula. That's not what I want. That looks really hard. I think that is the right formula, but it's not the exact version that is usually taught to stats students. Chi-square standard deviation. I was already looking at the site, wasn't I? Like that. Variance, not proportions. Interesting. Yeah, sure. Oh, I didn't see that was use metrics. You have the same color as Pen Center, at least on my screen. I found a solution over in this tab, but they don't really explain where things are coming from, so I'm just trying to see if I can like figure it out for myself. I think they use the chi-square formula in some way. You don't think it... So we were looking, but they're asking about sample standard deviation and the probability of getting a sample standard deviation. So that's what made me think chi-square, and I think that's what this thing is using here. But actually, I think they're using that x in place of chi even. What would you think to do here? Why do you get a range? And why do they flip the probability here? Okay, flip it back. Yeah, no worries, Spectry. University of Hawaii. Let's see what they have. That's the same exact page as the other one that I was looking at. What the hell? Wait, University of Saskatchewan and University of Hawaii are ripping off each other or something. I don't know. Okay, this is basically what I wanted to confirm, that this is indeed the formula for chi-square. We set the random sample size n from a normal population of standard deviation equal to sigma. Okay, let's use ChatGPT, maybe, yeah. We find that the standard deviation in our sample is equal to s. Given these data, we can define a statistic called chi-square using the following equation. Right. Distribution of the chi-square statistic is called the chi-square distribution. Chi-square distribution defined by the following probability density function. Who cares? Oh, were they asking? No, it's less than 75. Okay, so I think this is what we want. I agree with how this thing is plugged in. So our chi-square value is 13 and a half. And we want p of chi-square per sub 24 is less than 13.5. So I think we just be able to use a table, I think. Chi-square table. We have 24 degrees of freedom. And we want less than 13 and a half. Oh, that's why they're doing the range. 975 and 95. Areas to the right of the critical value. So you have to do 1 minus these, I guess. But if they use a calculator, they can get the exact value. Okay, so let's see if someone beat me to the punch here. Okay, no. So what can I link them? I can link them this page, I guess. Yeah, let's link them this page. Indeed, use chi. Is that an actual chi character? I think it's just x. This page. Oh, I already. Full reference to me when Googling. For info to help solve this question. We need the formula chi squared equals n minus 1 s squared over, oh god, I need a sigma character. Is this over in Ask Math? They have everything. They have the symbols you can just copy paste. Sigma's right there. For part A, the value comes out to 13.5. A calculator to get the value, or a table to get a range of values. Oh, yes, Petri. Thanks for confirming, though. Okay. Learn something, I guess old, because I think I already did learn that, but I just forgot it. Linear algebra 3, oh god. Why do I do this to myself? Oh wait, okay, no, this is parameterization. You have infinitely many solutions. I bet you I can remember this. And you gotta double parameterize? Okay. So, they missed class a few times and didn't learn how to do these. Please help. So, I mean, I bet you I could solve this actual problem, but they need to know how to do these in general. Get RAF first. Yeah, I'm just like wondering how I can explain to them in general. Yeah, getting RAF would be your first step. Okay. Honestly, does Elements YouTube channel have a video on like this situation yet? Because I would absolutely like link a video and be like, oh, this is a video that I thought was helpful. So also, I think a lot of students prefer to learn things from YouTube videos than like trying to read a text thing. But we can also just solve this first one at least for fun. Oh wait, I never turned my light on. It's only oh, okay. No worries, just a thought, Pen Center. So 1, 1, negative 4, 3. 1, 1, negative 4, 3. 5, 4, 4, 5. Okay, so if we want to get our REF first, let's subtract 5 times R. Actually, I think I would normally do the Roman numeral. So 5 minus 5 is 0. 4 minus 5 is negative 1. That's annoying. 4 plus 20 is 24. 5 minus 15 is negative 10. Now let's multiply this through by negative 1. And here's our RREF. Jeez. And so, oh gosh. This is the part that I always like falter on, but I think oh wait, no, is this actually our REF or do we have to no, we have to get the first row. Shoot. Start at 510? Okay. Okay, I scaled this up, that's why it's so massive. Also, shout out to the Elements YouTube channel. 510, share, start at, copy, heck yeah. Oh hey, this is actually exactly what I needed to remember too. Every pivot is 1. Pivot is the only non-zero entry in the column. Okay, that's what I was missing from my thing. So I should actually just like solve this just for my own information too. So yeah, okay, I was getting confused because I need to get the I need to get this one to be 0, I think. So I think we subtract 2. And so 1 minus 0 is still 1. 1 minus 1 is 0 now. Negative 4 minus negative 24 is positive 20. And I think you do actually a solid line rather than a dashed line like I was doing. 3 minus 10 is negative 7. 0, 1 minus 24, 10. Okay, that looks a bit better. And then I think what you do, says this is a basic situation, x1 plus 20x3 equals minus 7, and x2 minus 24x3 equals 10. So, okay, let me solve each of these for x1 and x2. Okay. So x1 equals negative 7 minus 20x3. x2 equals 10 plus 24x3. And then we say x3 equals, I think in their case they said s, just to like parameterize it. So you get x1, x2, x3 is equal to negative 7, 10. Then I think that's s down there? Oh, it doesn't show how to do that part? Okay. Oh, wait, no. For this, it's just 1. Or no, this is 0? Then plus s. Then negative 20. 24. And 1, I want to say? I think that's how you do the parameterization. That part, like, I learned it. You think that's good? Okay. I'm glad I have you to help confirm. Ooh woo. Okay. So. Oh no. Well, okay. Alcalaner did post a response here, but I think I can say a bit more. Do I still the YouTube video copy paste it? I do. Notice we can't get explicit solutions for x1, x2, or x3. However, we can solve, or we can put each row back into an equation and solve for x sub 1 and x sub 2. Both will be in terms of x sub 3. This is, this will be hard for a student to understand the way I'm saying it. x1 equals something plus something times x sub 3. Then you take x sub 3 equal to s, or any letter, the S for this problem. Called parameterizing. I want like one more sentence to explain like the next step for how you actually get to this format. And I'm trying to think how I should phrase that. With vectors. Based off your equations, if x sub 1 is equal to something plus something times s now, then the top row of the provided answer format will be those two somethings, if that makes sense. I feel like it's a little, it might be a little vague, but let's see if they reply back and see where exactly they get lost in this. We can go from there. If you can at least get it into RREF, we can go from there. All right. Oh, integration by parts or DM? I guess we should check the DM. Oh, okay. Let's see what this is. No one's answered it yet. Oh. Interesting. Let's see. I don't think this one will be that bad. Let's try it. Oh, you have to do the trick. You have to do the adding the integral to each side trick, I think. Because you can never explicitly figure out what... Well, there might be a fundamental theorem calculus thing if you can get the integral of f prime x alone. Let's see. Oh, jeez. Okay, we're breaking out the rag. Ah. All right, much cleaner. Okay, so we have, let's do green. The integral a to b f of x f prime x dx. And I'm not going to write the right-hand side dx, but that's what we want to prove. So here, we have no idea what f double prime x is, so I want the thing I derive in integration by parts to be the f of x. We want to keep everything in terms of f of x and f prime x. I don't want just the integral of f of x or like any f double prime x's here, because who the heck knows what those mean. So I'm going to derive the f of x, and I'm going to try to integrate the f prime x. Dx. So du is equal to f prime x dx. Integrating this, v equals fundamental theorem of calculus, f of x. Now uv minus v du. So that's f squared. I'm going to f of x squared, because the notation here is tricky, minus v du. And now we remember what's on the left-hand side, which is a to b f of x f prime x dx. And you can actually add this entire integral to both sides and divide by 2. Technically, well, it's f of x squared evaluated from a to b, I guess, like that. I don't know, is it squared on the inside or the outside, and does it make a difference? I don't think it makes, but let's just, I don't know. It's fine. So I'm going to add this to the other side, which means there's 2 in front. I'm going to divide by 2. So there's this 1/2 out front, squared from a to b. Then with this, we will get 1/2 f of a squared minus f of b squared. A lot of parentheses. Is that what we needed? It is. Okay, good. So yeah, they just need to know the trick with adding the integral to each side. So someone did like get to me or get to the question first. Let's see if we can respond to this person's follow-up. Nice job, Frylock. Roll to each side. So you get 2 times that integral, then divide by 2. Then you found the result of the integral. Let me see, I'm pretty sure Paul shows a different, shows the same technique in a different context. I don't think it's in this one. One of these might. No. This one is going to cycle. Example 8. Got Calc 3, where am I going wrong? There is an answer though, unfortunately. We can find a new question. We might be out of them for homework help though. Let's see. Same person, but this one doesn't have a response. Let's see. Okay, find an equation for g of x in terms of the function f of x. For example, g of x equals 10, f of 9x plus 8 plus 7. Oh, okay, so this is a weird way to phrase the question, but I think I get what they're going for. Or I don't know how I don't have a better way to phrase it, to be fair. So you're given this function here, f of x. It looks like a piecewise linear function. And you need to figure out what transforms they've done when going from this graph for f of x to g of x, basically. So we definitely have a reflection across the y-axis, like a horizontal flip, which means we're doing f of negative x here. So we should definitely have a negative sign on the inside there, which I agree with. We are shrinking the graph by, we're horizontally shrinking the graph by 2, because I see we end at 6 and negative 6 here, and then we end at negative 3 and 3 here. So that's, that is indeed a horizontal shrink, and that is a multiplying by 2. I think they've forgotten about the vertical shrink here, because in our y's are going from negative 4 to 4, but over here our y's are going from negative 1 to 1. So you want a 1/4 in front of this f of x, I believe. They said -3. I think they thought it was, they're trying to do a vertical translation, but I don't think you need a vertical translation. No. I think if you do the scaling, you're fine. Shift the graph down by 3. But if you notice, the y's for f of x go from negative 4 to 4, and the y's for g of x go from negative 1 to 1. I think we actually need to shrink it vertically, which means we do 1/4 f of minus 2x Okay, I think that's our answer here. Let's look for a different question. Oh, we got a DM. Oh, why can't I? Do I need to refresh? Here we go. Chi-square. Oh, yeah, so they get a chi-squared value that's off the table. Let me bring up another chi-squared. So we're in 24. Oh, gosh. Oh, my. 45. And they get 54. So we would say it's less than a 0.005 chance. You take the next value closest to it. On my chart, I see a chi-squared of 45.559 associated with 0.005 probability. Oh wait, is more than 150. So yeah. Wait, is it 3 zeros or 1 or 2? It's 2 zeros. Asking greater than, we don't need to do 1 minus that or anything. That the probability is less than 0.05, and because that's the best you can do with the table. Okay. It's a good question, because when you get a value that's off the chart, it's kind of hard to interpret that. I think I was still in homework help. Let's go back. Okay, this is where I just was. Let's look for a new one below this. As an answer. Math 1 plus, is this proof correct? Wait, did they double post it here? I know, it looks like a separate problem. All right, let's see if we can figure this out. Oh god, it's geometry proof? I don't know about this. Let's see if we can figure it out. We have a parallelogram, it looks like ABCD. Dude, I can't read this. It's too small. I don't know what the setup is. I'm tapping out already. So it's a geometry proof. Geometry proofs, they actually can be kind of fun in my opinion, but this type of proof is not fun. Let's go to a different one. Ooh, that's an interesting question. Does the local maximum's y-coordinate have to be greater than its nearby points or greater than or equal to its nearby points? And I think the answer is greater than or equal to nearby points. Like, it doesn't matter definition, I guess. It's like over the interval 1 to 2, is every value here a max, or are none of them max? Personally, I think I would. Well, I think they say either a max and a minimum. It's probably something to do with the second derivative. Like, there might be a situation the second derivative has to be greater, can't equal 0. I wonder how, I don't remember how it's defined for me. So, okay, by Paul's definition, and we do love Paul, I guess, oh, this, okay, like, we're looking at local maxima here, and this is less than or equal to. So in this case with the little line here, they'd all be minima and maxima. It's just a weird consequence of how we've defined it, at least in this. But I don't think every class is going to be like that. See if they say anything about the flat line case here. Extreme value theorem. It's been a minute since I looked at this. Let's just also look at this because I think it's gonna be related. Hmm. I never heard this called Fermat's theorem. That's kind of interesting. Okay, so either way, I think I'm going to link them to this page just to show an example of how it can be defined. So this person did reply and gave like the Wikipedia definition, but I don't think that means that an individual professor can't define it some other way in the context of their class, or at least won't. I don't know if they should or shouldn't, but I'm the professor. Has less than or equal to and greater than or equal to. A horizontal line would have infinitely many maxima and minima. I would look in your textbook / notes to see if there's a definition you've been provided, though. It may also involve f double prime x equal to 0. Or not equal to 0 or similar. And using equality signs, inequality signs. Okay. I got 2 DMs. Let's see what's new. This person just said thanks. That person said thanks. Or I do stuff like that all the time. Okay, let's go to learn math. Actually, I think I was already on learn math. Let's go back to learn math. Galois theory, pass. The determinant of this question? Oh no. A 4x4 matrix? And they're talking about row reduction. I'm gonna pass. I don't want more linear algebra and getting the determinant of a 4x4 matrix the way that I know it takes forever. So has a lot of posts on the subreddit, but I am not a fan of this formatting. I to the e to the 8 to the pi e? I have no clue. Some tetration going on, I guess, but let's go to Ask Math. I don't know what this is called. Let's see. Oh gosh, we have an essay. Oh, talking about if you take numbers and reverse them, their sum is still the same. DJX? Hey, Polygrangian. And hey, Sergeant Duck, for cosine rule, can you use any value for A, B, and C as long as it's consistent, or just be the opposite of your labeled? So it's something you're talking about a right triangle, Sergeant Duck? Let me try and draw this out so I can say a bit more, or so I can be sure we're talking about the same thing here. Welcome in, by the way. Yes. Get the spray. Thanks for the follow. Wait. Okay. Do you ever study combinatorics? Not really. I know the very bare basics of combinatorics. Integrals, yes, though. All right, so Sergeant Duck, it sounds like you have a right triangle here, and you're asking about how we're labeling the sides, A, B, C. And in theory, you can label them any way you want as long as you're consistent. So I think it'd be the second, or it might be the first thing that you're saying. Normally we'd say that C is the hypotenuse just by convention, and then A and B can go wherever. But what really matters here is the angle. So if we're taking this as our angle, This is the Greek letter theta. It's like a 0 with a line through it. We say that cosine of theta is adjacent over hypotenuse, so A over C. You can call A and C whatever you want, but it needs to be the sides that are consistent with the angle. Like whatever's next to the angle, whatever's the adjacent to the angle in the hypotenuse. It always has to be those two things, whatever they happen to be called. And so if instead you had the angle up here, I need another, I'll call it x. Cosine of x is now adjacent as b, and hypotenuse is still c. So it's all relative to the problem that you're working on. So I guess as long as you're consistent, they can be called anything you want them, as long as you're doing cosine the same way every time. And I hope that I'm interpreting your question right there. All right. So, sounds good, Duck. Thanks for the question. Happy to answer more if you have any. Oh, wrong browser. Okay, there. I'm not going to answer this question. Top 10 games? I don't even know. That's a lot of games to think of. Wait, what's happening here? My BF asked for me, but thank you so much. You dropped. Oh, that's nice. Okay, well, I'm glad I was able to help. Oh, okay, and then I also got a DM here. Well, Jed, it's a new year. I haven't played Talos Principle or Factorial this year. I mean, I do have actually the Talos Principle DLC that I technically could do, but I'm kind of scared of it. I don't top 5, I don't really know either. Fallout New Vegas and Dark Souls 3 are my top 2. I'll give you that much. I'd have to think a lot more for the others. The Company and Counter-Strike. That's all I played? I guess so. Oh, well, Phasmo as well, but... Colonists, yeah. Deviation differentiation by far the best topics in math. Sergeant Duck, I completely agree. I think those are super fun. Both of them. Those are in the top 5. Oh, for actual, like, played? Is that going by, like, stream time or, like, viewer count or something? Okay, yeah, for stream time. Oh, yeah, you've shown me this site before. Okay, yeah. It's neat. I should probably get more games in the rotation, though. This is for the past 65 days. Okay. Phasmo was my second, really. I guess I did kind of. I wasn't that consistent with Factorio. Like Factorio, I went hard in it, and then I stopped, and then I went hard in it again, and then I stopped. I guess that's why. likely intended answer is none. It's a bit simpler. $4 for wow, I did just a bit more Daisy than math. Man, I should have gone to 420 hours or something. I've definitely been doing more math than Daisy this year, though. It's been a lot easier to do like longer math streams with Zach's real analysis stuff to like go to when I run out of questions. Like, what the hell is this series, by the way? Like, if I have a steady stream of questions, I can keep on streaming math, no problem, but it gets really boring when I have no questions. What the heck is this? Is this sequence? M cubed plus 5 is odd, using proof by contradiction, using algebra and showing m is even. In this case, m is any integer, I assume? Or is m just a positive integer, or... Do they give you any guidance on that, Sergeant Duck? That's the entire question. I wish they were a bit more specific about that. I'm going to assume that we're talking about positive integers here, though. Because I feel like normally these types of questions are about positive integers, so case of proof by contradiction is basically you gave this up here. We're going to assume the opposite and show a contradiction. So we want to show that m cubed plus 5 is odd, so let's assume that it's even. And then usually how this type of thing works is we want to if m cubed plus 5 is an even number, it should be equal to some other number times 2. That's also a positive integer. And I think from here we need to split up into cases. So if m is even, take m equals 2l, I'll say, plus 1. Again, for some, this might be a little bit convoluted with all the variables that I'm using, but I think it's how you would do it. Hence, Jed, you don't like this? Or are you just memeing? Oh my god, Jed, you're right. Thank you. I was getting my evens and odds mixed up, but basically, we have to look at two cases here. One where m is even, one where m is odd. I was mixing my two cases. If m itself is even, then it should be equal to some other number times 2, just by the definition of being even. I did the +1 because that's odd. So let's plug in 2L up here and see if we can show some kind of contradiction. And that'll be half the proof. We still have to do the other case, but we want to show a contradiction in this case first. So we have 2L cubed in parentheses plus 5 is equal to 2K. So let's say 8L cubed plus 5 is equal to 2K. And I think from this case, or I think from here, we'd say eight L cubed is even, and 5 is odd. Therefore, their sum is odd and cannot equal 2K, an even number. Out of space there, but I'll write the number sign. Consider m equals 3 in the original problem. What is that? 3 times 3 times 3 is 18 plus 5, 23. That's odd. Or 1. Oh, yeah. 1 definitely doesn't work. No, it's 27 plus 5. I'm sorry, Jed. You're right. Dude, I can't do math. It must be after a certain point. Okay, so Sergeant Duck, what Jed just pointed out is that this isn't true for m equals 1 or m equals 3. So if m equals 4, 4 cubed is 64, that works. We must have to assume m is even. Is it that? Would it, so no odd number would work for this? Like 5 cubed is 125 plus 5 is... Oh, yeah. Yeah, I didn't try actually plugging in numbers. I was just taking this for granted. It says m is even. No. Contradiction. I thought showing m is even. That's part of the contradiction. Did I misunderstand the question then? Like, that's why I was asking what m is supposed to be, I guess, because you're told m cubed plus 5 is odd. So maybe I misinterpreted the question. Given m cubed plus 5 is odd, show that m is even? By contradiction? Oh, I guess I reversed this. My bad. I misread the actual question. I was doing the reverse of this. Sorry about that. Let's rewind. It was the and show that m is even part that made me thought it was part of the contradiction. Or like the very last part of that. Just the way that was phrased, I guess. Okay, so hey, Brian. Give in. M cubed plus 5 is odd, right? Proof by contradiction that m is even. Okay. Thanks for clarifying that. Okay, so since we're doing proof by contradiction, the thing we have to contradict, or the thing that we have to assume, is that m is odd to set up this proof by contradiction. And also, I like that we're using BWOC for a way of contradiction, like Enigma taught. I think I've been taking m as a positive integer, where I don't think we're really given that. So I think we still do our m is equal to 2l. We can use k again. 2k plus 1 for some k. By the given information, m cubed plus 5 is equal to 2l plus 1 for some l. I'm just using like the definition of an odd number here. Well, you can have an even and odd negative number, I think. I don't know if that really, I never see it come up though, so maybe not. I guess I do. Oh, you said integers. Sorry. No, yeah, but with rationals and reals, it definitely doesn't make sense. Anyway, so we set up this, m cubed plus 5 must be an odd number based off the given information. And from our assumption, m itself is equal to 2k plus 1. So let's plug 2k plus 1 in here and see if we can find a contradiction. 2k plus 1 cubed plus 5 is equal to 2l plus 1. That's annoying to multiply out. Is there a way that we can avoid doing that? Not that I see, unfortunately. So let's just multiply it out and see what we get. 4k squared plus 4k plus 1, 2k plus 1 plus 5 equals 2l plus 1. 8k cubed plus 8k squared plus 2k plus 4k squared plus 4k plus 1 plus 5 equals 2l plus 1. Combine like terms, 8k cubed plus 12k squared plus 6k plus 6 is equal to 2l plus 1. Here's our contradiction in the next step. Very vague question at the very end of an A-level maths pure paper. Oh, interesting. Yeah, I wish there were a bit more stuff about what m is supposed to be, but I mean, I guess it's safe enough to assume that's an integer, but we're nearly at the end of our proof here. Let's factor, we only need to factor a 2 out. We only can factor a 2 out anyway. 2 times 4k cubed plus 6k squared plus 3k plus 3 is equal to 2l plus 1. And this is our contradiction because here we have an even number because it's 2 times something, and 2 times something is always even. And here we have an odd number. So I don't know exactly how to say this like in English, but I guess we can go back to the original one. So since 2k plus 1 cubed plus 5 is even, it cannot equal 2l plus 1, an odd number. Therefore, m must be odd. Add odd. Box. I mean, I guess you could say that it's maybe not true for any m. I don't know. I don't know that actually. We've shown that m can't be even, but I feel like it doesn't mean it has to be odd. And I feel like that's what they need, or I think that's what they mean. 2l plus 1 even necessary? I like having it. God damn it. You're right, Jed. I forgot what we were trying to prove. I was like, oh, m is odd. That's what we're trying to prove. Thank you. All right, Sergeant Duck. I hope that kind of explains it. Sorry that I was fumbling through that so much, but I think I got there in the end. But if something that doesn't look right or you don't understand a part of it, please let me know. Whoa, thank you so much for the Prime. I really appreciate that. Well, if you have anything else, please let me know. Otherwise, I'm just going back to looking for questions off the internet. Not at this question, though, because it looks horrible. Which would chuck chuck. Bonjour to you too. Ipsum wacky stove? Get your maths mock on Tuesday. You want to get a B as you need an A by May to your aerospace. Oh, that's so cool. Aerospace engineering? Well, good luck. Yep, welcome on in, Ipsum. Glad to have you. Hope you're doing good. I don't want to do that. Brian, me or Ipsum? I'll do basically anything that's like calculus or differential equations and below. I'm not sure if you're asking me though, so sorry if you're asking Ipsum. Ipsum? Okay, sorry about that. Sorry, I need to realize that not everything's about me. Integration by substitution parts has your heart. Oh yeah, those are fun. There's some really like creative things that you can do there. Well, what I like most is differential equations, which of course involves integration a lot of the time. Well, some of the time, but I really enjoy integration too. There's some really fun integrals out there. Oh, it's like, what math do you like? Are you interested in? Maybe no, but if I am on your stream, it's because you were the first person you ever found a searching math streamer. Oh, really, Ipsum? Let me hook you up. If you're interested in math streamers in general, here's a whole list of ones who I know well and can recommend highly. BC Aura, aka Brian, also streams. And then another person who I can recommend is Actual Education. So I highly recommend you just go through the list here and hit follow. And of course, it's no obligation to, but if you're looking for more math streamers on Twitch, they are out there, and that's a pretty decent list to get you started. 1/3 Masters campaign, nice for luck. Just at school. Oh, okay, Ipsum. If you have any questions, please feel free to let me know. I think anyone in this list would be happy to help you out too if I'm ever not on. Many of us play math. Oh yeah, thanks, Jed. The Discord's a good place for screenshots because sometimes the problems involve like graphs or things like that, and you can't really type those out in a Twitch chat. Let's look at math homework help. I don't think there's gonna be anything on this subreddit though. So we'll probably go to the math Discord. Yeah, let's go to the math Discord. See what's happening over there. This song is a little annoying. Okay. Math Discord has been crazy this week? Oh, good. Well, hopefully crazy in a good way. Oh yeah, sure. Please do, Ipsum. I always prioritize people from chat. That's you who just joined. Amelia Clark is mommy. You can post your question in the math homework help channel, or you can type it out here in chat. Or if it's just like a concept, just like say what the concept is, and I'll try to explain it. Yeah, that's my check. Like things were. That is you. Okay, nice. Uh, oh wait, that's you, Sergeant. I'm getting my names mixed up. Well, hey, you know. Amelia Clark is pretty cool. So yeah, Ipsum, at any point, just put your question. Oh, okay, there. You know, the square root of -1 is I, but the sixth root of -1 is that. Oh, that's an interesting question. Yeah, so honestly, I feel like Penn Center might be able to give a better explanation, but let me try here. Let me Google roots of unity, because I don't know the explanation for this off the top of my head. I know that roots of complex numbers get very odd, or they're like, they're very different from, like the square root as your, or not a square root, but an arbitrary like root. Motion by a complex number is like vector rotation. Oh gosh. That's where I'm. Oh god, I feel like I'm gonna Google. I'm googling the wrong thing here. (26) or e solve z to the 6 equals -1. Okay, that makes sense. Ah. Oh god, this needs the spray. I need to do the spray every time, man. Okay. So in finding 6 root, you need to solve z to the 6 equals -1. This formula, yeah, that's what I was trying to look for. Uh, and BC Aura, I bought mine used off of Craigslist, so I think I looked at like staples and stuff just like briefly. Um, and they were like 80 bucks ish. I paid 25 bucks for mine. Just some dude was selling his, so that's what I unless like see if the whiteboard isn't visibly damaged, I think it's fine. You have to write out the solution. Third root of I. But we're expecting 6 values though, right? I want to find the nth roots of I think it is W. Yeah. Is this the technique that you mean, Penn Center? Okay. Drawing's probably at the end. Let's see. Oh shoot. Number 4? Oh god. I was scrolling around everywhere. I don't know where number 4 is. This is a cube root. Look at the procedure. Okay, wait. This is like the top of the page with Demoivre's. Right under the corollary. Okay. Oh, that number 4. Okay. I see. Sorry. It's hard with the stream delay. So I already started scrolling and then you said number 4. So yeah, if you're only just learning complex, stop scrolling. Okay, so yeah, doing 6th roots, it requires a bit more advanced knowledge of complex numbers than you might have learned. If you only just learned complex numbers, you might not have learned what's called the polar form of complex number, involving a radius times e to the power of I times an angle theta. Theta is a Greek letter. It's that like 0 with a dash through it. And it's commonly used to represent angles. It's like a, I'll just try and explain that quickly. I hope that's I'm not explaining something to you that you already understand, but if you have a complex number, I'm just going to try and do it like off to the right here. If you have a complex number, say 1 plus I, you can represent that in the complex plane in 2 different ways. You can do it like normal Cartesian coordinates, where you have like 1 is your x and 1 times I is your y, so you just have the point 1, 1. Or you can do things with a radius from the origin and an angle that you're going up. So we go a distance of root 2 with an angle of theta, 45 degrees in this case. And you basically find that by forming a right triangle here, which it's a little bit like maybe beyond what you need to like know, but basically 1 plus I is the same thing as what would it be? Root 2 e. Oh my god, I can't write. Root 2 e to the I pi over 4. And the root 2 represents the distance here from the origin to the point. And the pi over, actually, I should maybe put that in degrees, because you might not, in case you don't know radians, but times 45 degrees. It's probably bad form to write it with degrees, but just for the sake of not making things more complicated than they have to be. Represents the angle there of that right triangle. So, and using that form of complex, like these 2 things are completely the same thing, but using this form of complex number, I think is necessary to find a 6th root, like what you're asking. And you get some weird kind of irrational numbers, I think, which is why you get such odd numbers. You understand? Okay, I'm glad I could fumble my way through explaining that well enough. This is like I don't necessarily know like why this is true. I just know that it is an equivalent format and they mean the same thing. So my knowledge of complex numbers isn't very good, but I know like some general things like that. And so that's just like the introduction to what the e to the I theta thing is. But you actually have to work with it when doing the question that you said, which is basically z to the 6 equals 1. You don't know why it's true, Obi? I mean, why is like, it's weird. Why is e to the power of I times an angle equal to an angle? I don't know. I just know imaginary numbers are weird. Okay, I need pen center to do that complex analysis class because I would love to learn more about imaginary numbers. So they are super fun. It's equal to the coordinates. Well, yeah, I guess the angle is just the part up there. Okay. Okay. That's actually a good way of essentially a vector. Okay, yeah. General integral streams goes well, you do the complex course. Okay. I mean, to be fair, I have a book on it too that I just haven't even read. So I should probably, do that before telling other people to do it for me. You have to review it all anyway? Oh, okay. Oh, you're going to do some complex integrals with that? Oh, you have something ipsum? But I think how you actually go about some of the problem is you say that -1 is the same thing as the -1 plus 0i, and you put both sides into I don't know if this part is even necessary, but z to the 6 can be written in the form of re to the I theta to the 6. And is that just equal to -1 still? I'm just going to write equal to -1. I feel like maybe I'm making it too complicated. I don't know if I should actually go through and try and solve this. I feel like I'm going to do something wrong, but well, okay, we can try. E to the I6. This is just using a power rule where the power can get distributed to the R and to the E. So starting to work on a differential equation course. Ooh, cool. Second half is mostly complex. First half is warm up and up to Calc 3. Oh gosh, that'll be awesome. To 1e to the 30i? Oh. I see what you're trying or what you're doing with the power rule there. I have a hard time telling you why that's not necessarily valid. I know, and you do have a rule which is if you have the 6th root of something, you expect 6 different answers. If you have the 4th root of something, you expect 4 different answers. I think there's some kind of error in that, but I don't know how to explain it. I just know anytime you have a root of a complex number, you can't use your normal rules as far as I know, or at least you miss answers if you use the normal exponent rules whenever a fraction is involved. C to the n equals c as n different answers? Okay. And I think where you go from here is that you realize that this is -1 times e to the I times 0, like invisible because e to the 0 is just 1. So you're not actually changing the value of this. And you equate the r to the 6 with a -1 and the e to the I 6 theta with e to the I times 0. The principal, okay, yeah. I suppose I don't think calculators are good at complex numbers, depending on the calculator, I guess. And so I guess from the first equation, we're going to get r is equal to the 6th root of -1, which in complex numbers, I'm not sure how that's going to work, but the n theta. And then we have 6 times, looking at the exponents here, 6 times theta is equal to 0, but because this is complex numbers and it's like, it gets into trigonometry, but you have to do plus 2 pi, what do they use, L? L, for L equals 0, 1, 2, n minus 1. And I have a hard time explaining this without giving you a bunch more background information. Oh, you do understand? Okay. But yeah, it basically counts where, like, you can have the same angle represented many different ways, I guess. And that's kind of the very quick explanation that I can give you. If you solve this for theta, you get theta equals, what is that, 1/3 pi L? Or pi over 3L is probably a better way to write that. And the 6th root of -1 for the principal root. Oh, okay. For this one, I would just, for this part, it's hard for me to like give you all the background knowledge for why we have 6, or I guess, yeah, 6 different angles here, and why it's 2 pi. 2 pi is the same as 360 degrees, I can just tell you that much, but it's getting into like trigonometry and stuff, and it's a little complicated to give you a quick explanation of this. But it's basically the idea that if you have a 45-degree angle there, measured from the bottom, you could also go all the way around once and then do another plus 45. So you can do 360 plus 45 to do that same angle. You can do plus 360 again, plus 45, and that's 720 plus 45. And it's kind of the idea that you can keep going around in circles to represent the same angle with bigger and bigger numbers. And that's kind of the quick way that I have to explain it, but it's kind of complicated, and I don't have a good way of explaining, so I'm already fumbling my way through this explanation enough. How do we get the 6th root of -1? Because that just is in terms of reals. Or not in terms of reals, but... R is the distance to the origin. For -1, the distance is 1. It's the modulus of a complex number? Okay, yeah. But if it's the 6th root of... Oh, should it be equal to +1? Maybe that's my error. Okay. That's right, because I went from rectangular notation to polar. And in polar, I think it's equivalent. Or I guess I'll erase that negative sign. Because we're just talking about distance from origin. Okay. And the 6th root of 1 is just 1. And so solutions that we get are z equals basically, 1 times e to the pi, or e to the 0, 1 times e to the pi over 3, 1, or we're saying I pi over 3. 2 pi over 3. Plug in values for L here. Pi over 3 is just pi. So I'm sorry I can't give you like a more theoretical explanation for, oops, that's not right. For this kind of stuff, because it's just not my area of expertise. I like it, I think it's interesting, but I just don't have that good fundamental knowledge of how things work. So this gets you 1 times e to the 0 is just 1. And that gets you like a, you know, a seemingly real answer. If I did this right. Should I not say z equals that? Just one little bit equals 1, I think. Focus on the z. Okay, yeah. I hope I did it right. I honestly, I'm not completely sure. The R bit is correct? Okay. Let me check theta. Okay. Thank you so much, Penn Center. Why does my camera keep shaking? Sorry, one second. I'm going to shake the camera a whole bunch, and I don't want... Oh, that's why the camera's shaking. Okay. Oh, I need to charge my phone as well. Let me do that. Okay. Let me adjust the whiteboard now. The angle the vector makes, -1 makes an angle of pi. Oh, shoot. I did that wrong. Yeah, you're right, Penn Center. Frick. I said that the angle is 0, but -1 is over here. It makes an angle of pi. Or 180 degrees. And, oh my gosh, okay. That should be pi. So that's pi. So pi, pi over 6 plus I was wondering why, because it was like one of the answers was like 1/2 plus something weird, and I didn't see where that came from. So I think this is why I missed that answer. Okay, and then from this, your radius is still 1, so you get e to the pi over 6, e to the I now 2 times pi over 3, or sorry, 1 pi over 3. So pi over 3, did I write pi twice? Thank you for the follow, by the way, Ipsum. I appreciate you still following, despite me like explaining this horribly, but I'm glad you're still here for it. So pi over 3 plus pi over 6. Is that a half? That's 2 pi over 6. Yeah, that's pi over 2. E to the I, now 2 comes 4 pi, 2 pi over 3? I hope I'm plugging these numbers in right. That was for L equals 0, L equals 1, L equals 2. L equals 3, we get 3 over 3 is just pi. Pi plus pi over 6 is 7 pi over 6. L equals 4. E to the I, 4 pi over 3 plus, so that's 8 pi over 3, 8 pi over 6, which is 9 pi over 6, which is 3 pi over 2. We can check this in Wolfram Alpha too. And then finally, L equals 5. That's going to be 10 pi over 3, or 10 pi over 6, which is 11 pi over 6. I'm writing it kind of bad, but let's see what Wolfram Alpha says about this. It's a 3 pi over 6. Okay, so I simplify my fraction a bit, but I think it's 3 pi over 6, which is 2 pi over 3. Wait, 3 pi over 6? No, that's pi over 2. Okay, right? 5 pi over 6? I might have messed that one up. Two pi is a whole round? Yes. Ipsum, the conversion rate is that 2 pi is 360 degrees. And so if we go just pi, that's 180 degrees. So like you always start from the positive like x-axis here, or I labeled it real, but whatever. And you go like around this way just by convention. So you always make circles starting here and going around counterclockwise. And that's something that you'll learn about like in a trigonometry class. I think I did some bad simplifications here in my fractions. Penn Center's thing is probably right. When L equals 3, that is 5 pi. No, sorry, when L equals 2, 2 pi over 3 becomes, yeah, that's 5 pi over 6. And I probably did a bad simplification there before. 8 pi is 9 pi. Oh yeah, that does simplify. I think that one was okay. Okay, and let's plug into Wolfram Alpha to verify this. Top 3 cod characters? I don't know, for luck, I'm sorry. Z to the 6th equals -1. Survey says, let's give me in rectangular. Oh wait, oh, that's so cool. I didn't know there's a drop down like that. We're getting negative exponents. Maybe it's the same thing, I just express it differently. Minus pi over 2 is the same thing as 3 pi over 2. I think we get the same thing, just Wolfram Alpha did it slightly differently. You get decimal approximations? Oh, okay. Pi over 6, right. Pi over 2, is that in there? Right. 5 pi over 6. It's the same thing as minus pi over 6, I guess. Man, I wish Wolfram Alpha did it in a different way, but I'm going to say our answers match at least. There might be a slight error somewhere here, but I don't know, the minus 5 pi over 6 is the 11 pi over 6, I think. Yeah. That's right. Oh, yeah, Penn, that's a good call. So yeah, I think you get some weird decimals because you have cosines and sines involved. I guess these are all, well, yeah, there's gonna be some irrational numbers involved. So actually, what is root 3 over 2 as a decimal? .866? I think we had a .866 somewhere in one of the example answers that you gave. Here it is. Oh, yeah. Open thread. Yeah, 0.5. So yeah, I see. It's gonna be I want to see if I can spot the exact one that's gonna be. So it's root 3 over 2 plus a half I. It, no, the first root is gonna be whole numbers. I see one of these ones with pi over 6. One of these last three, I think. I don't remember my unit circle. Let me see. The reason why this is true is it's a little bit hard to explain offhand. And I'm sure this looks crazy. You're excited? I mean, well, with pi over 2, it's going to be like 0 or 1, right? I think it's got to be, like, let's look at pi over 6, like the fourth one. Root 3 over 2, 1/2. So that's root 3 over 2. Cosine of pi over 6 is root 3 over 2. Yeah, okay, I think it's that fourth root. So if we put cosine pi, oh shoot, over 6 plus I sine pi over 6, I think this will get to that one answer that you said. Ipsum. 0.866 plus 0.5 I. Just trying to relate it back to the example answer that you got earlier. That one. Yeah, so so I'm sorry that I like there's a lot of things that I'm kind of glazing over here with um like the whole pi over sixes and why they mean angles and things like that, but I hope that at least kind of like piques your interest a bit without getting too without getting into the nitty gritty too much of like why I did some of the things that I did here. And thanks very much for the help with this pen. It has to choose one. Yeah, that's a good point. It's a branch cut. Ooh, I haven't heard that term. That makes sense though. And so if you're ever curious about this stuff in general, I highly recommend you use Wolfram Alpha. Because Wolfram Alpha, it'll if you give the right like equation as input, like this version, it'll give you all the roots as well. Oh yeah, some go to sleep. Uh, thank you so much for coming by and for the question. Bon nuit, I think that's how you say it. We find take a branch. Oh, you just like we find inverse sine x. Take a branch. Well, isn't inverse sine already restricted? Or are you just like assume that the like arbitrarily restricted domain to like minus pi over 2 to pi over 2 or whatever it is for inverse sine? Even though there could be more answers if you do plus 2 pi? Oh, okay, okay. Oh, yeah, okay, that makes sense. I guess, yeah, you have to start out with restriction on sine, and then you can define the inverse, not the other way around, defining the inverse and then restricting it. Same with f of x equals x squared, you have to choose a side. That okay, yeah. That's a nice way of putting it too. Okay, let's see if we have any new DMs or anything we replied to. Nope, okay. Maybe now we'll go over to the math Discord. Makes you excited to discuss complex variables. They are fun. There's some very weird things that happens with them. Oh god, speaking of complex numbers. Wait, what are you solving? I guess simplify this, they mean? I think you would want to put this in exponential form, as long as we're talking about complex numbers. And then you can use log identities. Think of it as Cauchy's. I assume that's separate from like the Cauchy sequence stuff that we've been doing in like the real analysis. Let's add a bunch of 2 pi I. Wait, I haven't heard of that one then. Let's see if I can puzzle this one out, I guess. Been talking about complex numbers anyway. Complex integration? Oh, okay. Actually, I don't know why. I can just copy the problem down. Okay. We're gonna call that good enough. Let's see if we can... We have... They say log, I assume it's a natural log. Minus 1 over root 2. Plus minus 1 over root 2. I. And so I assume our trick is that we put this into exponential form. So r is equal to root... I'm going to say root 2 over 2. Actually, no, that actually makes it harder for this, doesn't it? Which is equal to half plus half. So you get 1/4, and that's just a quarter. Oh, is there an identity that just does that for you? The capital letter means the principal branch cut. It's plus IRC? I thought it'd be multiplied, because if you got it into I mean, I'm sure I'm wrong here. If you got into RE to the I theta, I thought my plan was to do I theta log R. I definitely trust your word over mine on that though. Oh, for capital L on the log? What happened to my radical? It went away. Oh, wait. I did it horribly wrong. 1/2 plus 1/2 is 1. I should know better because that's unit circle as well. I think someone beat me to it. Okay, they use the same formula. So yeah, I guess it's just, I was about to do it wrong. I wonder why it's plus. Oh, I know why. You have to do the addition log identity first. Wait, The magnitude of z was correct? Okay, I mean, the questions are already being answered on the Discord, but just for my own knowledge. Your R value... It should be 1. It's correct now, right? Before I said a half plus a half is a quarter. Because I'm really good at math. And so I did this identity completely wrong. I see why... You have to do log r plus log e to the I theta, and then you do the exponent. Oh, okay, bye, Marker. It was nice knowing you. I mean, this is a pi over 4 plus pi. 5 pi over 4. I'm calling it that. It's already answered it in the Discord, so I guess I shouldn't, or I'm not, maybe I shouldn't spend that much time on it. But let's see what people like are saying and see if I got the right answer. What's happening with this? Or we've already taken the arg, right? So it's just I times pi over 4? So the answer is I times 5 pi over 4, because log 1 is 0? Or is log of 1 in complex numbers a bit harder? Arg is only defined on minus pi to pi? Oh. Really? Okay, well, now I'm curious. This is basically a complex number stream, or a complex number study stream now, I guess. This angle's the argument of z. We need minus pi plus pi over 4 for r's. Oh, they're doing minus pi to pi. Minus 3 pi over 4 should work? Yeah, I was just wondering which one you would take between pi over 4 and... Stream dead? It looks like it's still okay on mine. Just your... Okay, good. Or, well, I'm not good that your computer isn't working, but... Okay. Arg is only found on minus pi to pi. Oh, okay, yeah, duh. It's just... sorry, I was thinking it was only half. I thought it was like 0 to pi for some reason. I was like, well, how do you choose which quadrant? But minus pi to pi, duh. You just do... Yeah, minus pi plus pi over 4. Okay. I times minus 3 pi over 4 is our answer? Okay. Let's see if the people in the Discord are saying that. What are they talking about? Okay, so they get to the right argument, it seems. Let's see what this person replies back with. Yeah. Well, I thought the old one was struggling with that. Okay. So yeah, I'm not gonna like jump into this because I think this Dr. MATLAB plot person is handling it, but I'm interested to see the discussion. Okay. Yeah, it is a little weird. Oh, what did I do? They got it now. Closed. Oh, okay. They're good with that one. Wow, why aren't these getting cleaned up? Dingle Z jumps by 2 pi as soon as you cross over pi. For arg. Oh, yeah, because you have to... By 2 pi as soon as you cross over pi. I was saying like the issue they just had with like how to give the argument or arg. I guess we did jump by 2 pi. You're saying it's weird? No worries. I'll say a lot of these look like resolved threads that aren't getting cleaned up. Or like kind of like threads that have gone cold. Oh. Oh no. A equals B equals 0 gives a consistent matrix. Minus pi. Really? A Clopen interval? Or if it starts with open, would it be Ozd? Obst? It's that ray along the real axis. Yeah, it is. Oh, I guess if it's going to repeat itself, it might need to be half open. Just that ray along the real axis. Okay, I think I get what you're saying. Where you try to make your angle, but once you go past pi, you have to like back up and go the other way around. Sounds good, Penn Center. Thanks for the backup on these questions. I'm sick of linear algebra. I'm gonna look away from that one. Let's look at the new ones. Oh, they're reopening this. If I have HA, do I need to look for SA? I don't know. Oh God. Okay, I'm not gonna look at the context here. compounding interest. Wait, we need the context of the question. Oh, wait. They don't give us what bank 1, 2, and 3 are, but maybe they're only asking about bank 4. I guess they are. It seems like they have a pre-programmed thing for compound interest with weekly payments. Let's see what the formula for this looks like, because I don't know it offhand. I want to know the formula. Tell me the formula. Ugh. Ugh. That's just like, that's not for regular contributions though. That's for the same amount. Top three, I don't know for I look, I guess soap and price. Uh, I think his name was Sergeant Foley in Modern Warfare 2. He had a really iconic voice. Like I really liked that like voice actor. What's happening here? I don't want to know what's happening in that thread. Hmm. So there's a lot of threads open right now, but most of these aren't really. There's not really a lot happening in these. So it's not that I can like help with. So let me take a look back if we have more DMs. I guess not. See if there's a new thread that we can. Multivariable limit. Squeeze theorem to prove it doesn't exist. This feels very polar. X squared plus y squared. But you can't really approach, it doesn't make sense to approach from a circle. Well, I mean, what if you just approach from the line y equals x? I don't really know how to interpret this part either, to be honest. Approaching from the x-axis versus approaching from the y-axis, like, it's the same function, but with different variables. I need to look at multivariable limits again, because I don't remember them well enough. Where do they do multivariable limits? Maybe here? That's where. Oh, well, here they have a simplification. Okay. As x0 approaches 0, 0. Oh, they haven't taken the limit as x goes to 0. That's why I'm getting confused. Okay. So if you actually do the limit as x goes to 0 here, you get 0 over 0. Same with the y's. So maybe those aren't helpful. Taking y equals x seems like it could be helpful. Trying to debate how that would work out. We still get 0 over 0, actually. Do you... It might be more helpful to multiply the top and bottom by the radical. Let me make sure no one has already gone on this. No. Okay. Let's see if we can puzzle this one out. So, hey, State of Milan, can you explain logarithmic functions? Yeah, sure. It's good to know. I'll actually just clear off the whiteboard too. So, if you have a specific context that you're asking this in, let me know, but I'll just give you like a base explanation of like where logarithm comes from and why you might want to use it. So let's start out. So logarithms are kind of the inverse of an exponent. So if we have the equation 2 cubed equals 8, This is an equation in exponential form, we would call it. That's perfect? Okay, good. And we translate it into logarithmic form using the following way. So start by writing log. The base is the base of whatever's being raised to a power. So here 2 is the base because it's being raised to 3. So our log is base 2. And now what goes inside the log is whatever it's equal to, so 8. And the logarithms are always equal to an exponent, in this case 3. These two statements here are completely equivalent. They mean the exact same thing. The result of a logarithm is always an exponent, 3, just like the 3 is up there. That's like the most important part. That's the most important thing about logs that I can, I guess, tell you easily. And why we want to do this in the first place is whenever we have an equation where something's in the exponent that we need to solve for, like if we have a variable up there, if we have, let's give a slightly harder one, but still not too hard. 3 to the x equals, let's call it 81. Well, we want to solve this equation for x, but x is stuck up here in the exponent. Like, we can't do our normal, like if we had 3 times x equals 81, we can divide by 3, but we don't have an easy operation that we can do here to get the x to be alone, aside from a logarithm. So let's put this equation into logarithmic form. So let's follow the exact same process, write log. The base is the base of what's being raised to a power. It's of whatever it's equal to, 81. And then it's equal to the exponent x. And I can see we've now isolated x, and we just have to calculate log base 3 of 81. And that's something you can plug into your calculator. If you're good with your powers of 3, you can know that it's just 4, because 3 to the 4th is equal to 81. And if you did have to plug that into a calculator, you have to use something called a change of base, because calculators don't know log base 3. Calculators normally only know log base 10 or log base e, which is also sometimes called the natural log ln. And that's kind of like a matter of convention. So some calculators can do any base you want, but often they only know base 10 or base e. And e is just an irrational number like pi. If you haven't learned it, e, don't worry about it. And so if you did have to plug this into your calculator because you weren't sure, you would do something called a change of base, which is, if you want to put it into base 10, this log right here is equal to log base 10 of 81 divided by log base 10 of 3. It's the same format at every time. Change of base. And log base 10 is something your calculator should know how to do. It might just be log without a base at all, and there's an implied 10 there. But that'll give you 3. And you can do any base you want with this formula. Like you can do 9, 100, a million, whatever base, as long as it's the same and you follow this like format. And you just ask the question, in what context should you use log? Oh, I might have written that poorly. So you're asking like, in what context should I use the log base e? And so I had written in parentheses ln. I didn't mean it as log base e of ln though. Like I don't mean it as a function like this. I mean that sorry, because that's a very like poor way for me to have written that. So if you haven't learned about e, like I won't stress about this too much, but e is called Euler's number. Oops, if I can actually spell. And it's about, I think, 2.71. And it goes off to infinity just like pi does. And it turned out to come up very often in math. So it just kind of comes up in random places like exponents especially. And it comes up so frequently that instead of writing log base e every time, mathematicians have abbreviated it to be ln, the natural log. I don't know why the L comes first. I assume was originally written in French or German or something. But ln, like if you have if you have log base e of, let's just say 10, you could write it you could also write it as ln of 10. It's just an abbreviation for log base e. And when you do want to base e, it kind of depends on the context. Usually it's like I just studied applied math, so we just always did everything with e because that's what mathematicians do. But if you do like engineering or something like that, or physics or something, you might use other log bases. It's kind of context dependent. You can express anything you want with whatever base you want. It's just kind of some things are a bit easier. So yeah, I hope that that helps you. If you have any other kind of questions about what I've said, or if there's a part of logs that I haven't explained that you've heard of and want to hear more about, please let me know. But I hope at least like that helps you out a bit. Helped out? Awesome. Glad to hear it. I found you randomly and you saved us, no cap. I'm glad to hear it. That's exactly what I'm here for. If you have anything else that you want to ask, I have a Discord where we can ask things. And I do this stream on Tuesdays, Thursdays, and Saturdays starting 3 hours ago, whatever that is in your time zone. So I was happy to help with stuff. And so unless there's anything else that people are going to ask me in chat, I'll go back to looking for questions off the internet. And I was interested in this multivariable one. Oh yeah, exponential function and logarithmic function. Yes, I'm happy to do that too. And so I assume you're talking about their graphs. So let's take a relatively simple example here, and let's look at y equals 2 to the x, and how it's different from y equals log base 2 of x. So let's draw our x and y axes here. And I'll plot a few points, and then I'll just kind of fill in the rest a little bit. So if we have 0 for x, that becomes 1. So we have the point 0, comma 1. We have the point 1, comma 2, 2, comma 4. And an exponential function, you've probably seen a graph of it somewhere, but the idea of exponential growth, it starts slow over here, and then it very suddenly like turns up and increases super quick. So that's y equals 2 to the x as a graph. It's called an exponential function, and it has exponential growth, which is where that name comes from. And now in blue, let's graph log base 2 of x. So I'll kind of fill in some of the values here like I just did before. If you plug in 1 for x, you get 0 for y. An important note here is that you can't plug 0 into a log ever. Log base 2 of 0 makes no sense. Because you can never have a number that is raised to the power that gives you 0. Like 2 to the power of 0 is equal to 1. And there is no number for x here that gives you 0 there. Maybe there's some weird imaginary thing that I'm not aware of, but for our purposes, 2 to the x equals 0 does not compute, and log base 2 of 0 does not compute for the exact same reason. So, the graph, when you plug in 4 for x, you get y equals 1. Going back to the actual graph here. I'm making that point because when we draw this line, the log is going to go from very close to 0, but not quite. And then it's going to level off like this. So this will never quite hit 0 in the same way this exponential will never quite hit 0. And what you might notice is that these are reflections of each other. If you take the exponential and flip it across that like that diagonal line, you get our log. And that's no coincidence. It's because logarithms and exponentials undo each other. They're inverse functions, if you've heard that term. And so you get this like interesting like symmetry around, it's actually the line y equals x. That part isn't as important though. Or they're basically like mirrored from each other. And so was I interpreting your question right there with that explanation, or was there a different? Oh, maybe you're asking about something like that. Minus 4 to the 3. Okay. Sorry if I gave you an explanation you didn't need there. Can you solve for the x when y is 0? Okay, let me write down what your problem is and see if I'm interpreting you right. Oh, you didn't? Okay, good. So how I'm interpreting it is maybe you have an equation y equals minus 4 times 3 to the power of negative 2x plus 1, like this, and then plus 36 down here, and then you have y equals 0. Am I interpreting you right? Yes? Okay, good. So yeah, we can definitely solve this for x. I would start by, it's like this 3 to the power it has our x, so let's get rid of everything else around it. Let's get rid of the 4, let's get rid of the 36. So let's start by subtracting 36 from each side. That'll give us negative 36 equals negative 4 times 3 to the negative 2 times x plus 1. Now let's divide each side by negative 4. We'll get 9 equals 3 to the negative 2 x plus 1. So I hope you're with me so far. Now we need to use our logarithm form. So we've gotten everything else around, kind of like the exponent to be cleared out. So let's put this into log form. So we're saying log, the base is 3, like always, of whatever it's equal to, 9, is equal to the exponent, negative 2x plus 1. Okay, good. And so now either with a calculator with a change of base, let me write how you would do that off to the side. If you're not sure what log base 3 of 9 is off the top of your head and you want to use a calculator, you'd want to do the change of base with log base 10 of 9 divided by log base 10 of 3. Or if you're like me and you've done logs a bunch of times, you would look at this and know that log base 3 of 9 is equal to 2. So either way, I'm using a trick because I've done logarithms a bunch of times, but if you're ever not sure, that's what you can plug into a calculator. So log base 3 of 9 is equal to 2. And then it's still equal to negative 2 times x plus 1. And now this is a normal algebra equation. So let's divide each side by negative 2. So you get negative 1 equals x plus 1. And then subtract 1 from each side. And you get negative 2 equals x. Is that right? Yeah. Perfect. Awesome. Glad to hear it. If you have more that you want to see, please keep asking questions. You should be good? All right. I'm not going to be streaming for a ton longer today, at least. But I'll be streaming for a bit longer. And if you have a question in the future, I don't know if that was actually you, but there's always the Discord too. Okay. So no one replied to this multivariable limit yet. So let's see if we can get on this one. It was you? Okay. And so I'm not sure if you use it, but if you're aware of twitch.tv, the live streaming site, there are more math streamers over there too. So right now I'm dual streaming both on Twitch and YouTube. If you do use Twitch and you're interested in math streams, I think it's the right command. Let me see if Nightbot knows what it means. Yeah. There's a whole bunch more math streamers who are happy to help answer questions too. But of course, if you don't use Twitch, then no worries. But I just want to put those people out there too. So in the meantime, I'm just going to go back to looking at questions off the internet. So there's still this calculus one that I'd love to investigate. So let's try that. Oh shoot, I didn't take the cam down. Okay, so we have the limit as xy approaches 0, 0 of x squared plus y squared over root x squared plus y squared plus 1 minus 1. Okay, so I had an idea for this that I kind of forgot. What was my idea? Oh yes, I wanted to multiply the by the conjugate. Or I guess rationalize the denominator is a better term to use here. Plus 1 root x squared plus y squared plus 1 plus 1. Okay. So that's x squared plus y squared root x squared plus y squared plus 1 plus x squared plus y squared. Hey, is that Nico? What? Sorry, I had to like get closer. This is a calculus, a multivariable calculus problem with given the limit of this as xy approaches 0, 0. I'm not sure what the answer is. It's I'm seeing maybe multiplying by or rationalizing the denominator is going to help us here. I think it will. Yeah, this is actually a really nice simplification. Okay, this is the answer here. Because we get x squared plus y squared, and I'll show the original post where I got this question from in a second. But let me finish this train of thought here. Over x squared plus y squared. And now we get a cancellation here because x squared plus y squared, x squared plus y squared, x squared plus y squared. So we just get the limit as xy approaches 0, 0 of root x squared plus y squared plus 1, which is equal to 1. Okay. I like that. It's a nice trick. And if you have, or if you're not familiar with calculus, Nico, I wouldn't worry about what I'm doing. But welcome in, by the way. If you have a question, feel free to let me know. Whoever's here to hang out, it's completely fine too. Okay, so this is where I got the question from. So let's see if no one else has answered it. And so I want to address their attempts before I even get into how I did it. Because they tried to approach from the y-axis, approach from the x-axis, and then approach from the y-axis, and they seem to have gotten stuck. They never actually tried plugging in 0, 0 for x and y. And they tried to use squeeze theorem to prove it doesn't exist, which seems like a non-starter. Because I think squeeze theorem can only be used to prove that it does exist, as far as I know. Oh wait. And maybe there is some technique that I'm not aware of. I'm actually you're really postpone studying for your math finals. Well, hey, it's still like math related. You know, you're not slacking too hard. What math class are you taking, if you don't mind me asking? Mathematics, spatial structures, and parametric design. Interesting. That sounds like a university level class. It's like rather than like you know, like grade 1 through 12. Spatial structures and parametric design. That could be a lot of things, I guess, but it sounds like it'd be an interesting class. Industrial designer. Oh, cool. Well, good luck with your finals. Okay. So when you look at the limit approaching from the x-axis and the y-axis, you still need to actually plug in 0, 0, or 0 for the x or y that remains, you'll end up with 0 over 0 for each, so those don't end up being helpful paths to look at. Wait, they're trying to prove the limit does not exist. Did I just prove it does exist? I guess I did. Unless there's a discontinuity and I did some invalid math. Let's see what Wolfram Alpha has to say about it. X squared plus y squared. You have a square root. Plus 1 minus 1. Right? Right. 2? How do you get 2? Oh! Yep. I forgot about that cancellation. I chopped it off. It should be root x squared plus y squared plus 1 from that, plus 1 from that. It's equal to 2. Glad I checked in Wolfram. With using squeeze theorem for three-dimensional functions, or using it to prove a limit does not exist. Maybe it's valid, and I just don't know. Either way, I think this limit does exist. Try rationalizing the denominator and seeing what simplifications happen, i.e. multiplying by this one. Okay. Okay, that was a fun one. See if we can find another question. Oh God, is this person in heaven? Why is everything glowing? Is this correct? The equation was x cubed minus 18x. Wait, minus 134. Oh, they're using, oh God, the simplified cubic formula. I don't want to do that. When there's no x squared terms in a cubic, I think there's a simplified version of the cubic formula, but it's still super complicated. You need to make a mistake with. And since I'm like 3 hours and 20 minutes into a math stream, I don't really want to get that deep into like arithmetic. See what's up with this one. Wait, they were doing F of U intentionally, right? Just so they could write FU? Like, if I was writing a math textbook, that's the type of thing that I would try and slip in there. I never actually, I don't, if I had looked at a proof of the chain rule, it was in like a calculus class during a lecture and I glazed over it completely, not caring. So let's see if I can understand this. I might not be able to understand it though. They're asking, so in the first principle doesn't work. It makes a longer proof with a few extra steps. Well, I wish they posted the entire thing then. Or like what the shorter version was too. F prime U. F prime U2 textbook. Oh, I'm just laughing at the whole like FU thing, but the question was basically the textbook. It's a proof of the chain rule. I assume it's just a Calc 1 class. And apparently there's a simpler version of the proof that but doesn't always work for certain types of composite functions. And so they do this proof down here that's longer. And they're asking what type of function wouldn't work for that short version of the proof. I wish they said what that short proof was, though. I might ask them for that. Hey, Red Tree. When doing proofs, what is the best way to keep from doing steps that break the proof? That's a good question. It's something that I struggle with myself, so I maybe don't have the best answer, but that's what I try to do is at each step just ask if there's a counterexample to what you're saying. I don't have a very good technique in general, though. Or, like, you know, that's not a perfect, or that's not like a perfect thing, because when I try to prove something, I'm very, like, in my head. Yeah, don't fuck it up, basically. It's like, I don't know, I've heard of, like, Lean, which is, like, some kind of, like, kind of coding language that'll check proofs for you if you learn how to, like, give it a proof that it understands, but I never try to use it for myself, though. How do you say this if k not equals 0? Oh, by definition of derivative. I see what they mean. Yeah, Pen. I think I agree. Let's see if someone else has posted. Oh. This person... Wow, this person just knew what the shorter proof would be. Okay, I'm glad I refreshed. We may have g of x plus h minus g of x equals 0 for many values of h as h approaches 0, so the first vector is 0 over 0. Okay. I'm just gonna, I don't know if I would be able to come up with that on my own, so I'm just gonna let that stand. I do have a reply though. You've got mail. interest. You can say, you know, it's interest. Oh, okay, squeeze your shot in the dark. Okay, I think I was in Learn Math. Please help, smiley face. Oh no. Word problems. Pigeonhole theory, or pigeonhole principle. No, and that's like number, no, I'm okay. I don't want to look at these. The pigeonhole principle. I feel like I learned it once and then I forgot it. I don't know. If I wasn't like 3.5 hours into doing math, I might be more willing to like learn new things, but I feel like I'm gonna like mess things up. Um, Cosine has an answer. From Vamonos. Press a 3-step rotation and a single-step rotation. Well, can you just multiply the matrices? I think I remember this one. Any 7 cities on Earth, you can prove at least 5 of them are in the same hemisphere? Oh! I feel like I've heard that fact before somewhere in one of my classes or something. That's a pigeonhole principle thing though, right? Yeah, it feels so weird because it feels like you choose. I guess it's because of the way that hemispheres are defined. Because you could do like draw a great circle connecting 2 cities and see what happens. I feel like I feel like my drawing is gonna be bad. Let's see. I'm sure there's gonna be a lot of explanations of this online, so let me just look at one of those. Yeah, there's no problem I can't not solve. It's true. There's no problem that I won't walk away from. This is 5 cities on Earth are chosen, and they said a hemisphere for at least 4 of them. Cities on. Oh. Well, I didn't know this part. That makes sense. Okay, if it's on the equator, then you must have either 3 of the cities, or you know, you have at least 3 cities on one side of that line. And so if it's on the exact equator, then I guess that means there's 5. But that's interesting. I guess if it's exactly on the equator, would it be in both hemispheres at once? I guess it would be. That feels like cheating, I guess, but it makes sense. On the compactness of the circle? I don't know what the compactness is. How do you have a circle that's not compact? Maybe I'm getting you started though, and I shouldn't. I guess I don't know what compactness means for this. The equator is closed, so it contains its limit. Oh, okay. Hey, cellophane. Zero is not a number because it's neither positive or negative. Maybe I don't know the definition of a number. Is zero the equator of real numbers? I guess so. You know, what if you looked at the real number line and then you put a second real number line perpendicular to that one, and then you make them on the surface of a sphere and you extend the origin? I don't know. I'm kind of losing my train of thought now with that, but it's a placeholder, the username or zero? You know, if you want to be named cellophane, you know, I'm not gonna judge. Equator and prime meridian? Okay. What's happening with this one? I can feel my brain like losing battery, but they need to do three-dimensional rotation, basically. I don't think the rotation matrix for 2D. I assume there's one for 3D though. Triton matrix magic. Oh, maybe they know more than me already. Find the axis and angle knowing only the 3D vector. I think it depends on how this function works. Because could you take the 3D vector and just convert it to spherical or something? I don't know. I feel like I don't know enough about this to comment. Oh, what's this? Oh, you have a video on it. Well, so they're talking about. Oh, you have it in 3D. You call them E1, E2, E3? Oh my gosh. It's textbook we use? Okay. No, I'm just like, I know like X1, X2, X3, but when you start using E's, I'm like, ooh, that must mean you're doing some serious math. That's a three-dimensional. So if you want to do all three of these simultaneously, do you multiply the three of these together? Hmm. Rotating them one by one? Okay. I think I'll look at this for myself later. I don't know if I feel confident enough to like try and comment on that person's thread though still. R1, R2, R... Oh, that makes sense. There's a new comment on this one. What were they saying? Oh, doing with polar... Okay, I was wondering how you might use polar coordinates for this. Either way, you get the same result, though, I would imagine. The film was so weird. Oh, yeah, for the rotations, I did not think that they would look like that. Because I've only seen it for 2D. I guess the origin in polar coordinates is still the origin. It's still like 0, 0 in terms of r theta. Well, I guess you reduce it down to a single variable with r. Oh, sorry, this one was already answered, but someone found an alternate way to do this. It's limit as xy approaches 0, 0 of x squared plus y squared over... Actually, I have it written on the board too, but... root x squared plus y squared plus 1, and the root, and then minus 1. The thing at the top here. And so I just rationalized the denominator and found that the answer is 2. But what Alcalaner pointed out is you can... It looks a bit simpler if you put it into polar coordinates. You do the exact same technique, though. I guess you're allowed to use L'Hopital's now, though, with a single variable. Well, I think rationalizing is still easier than doing L'Hopital's. Hey, SPQ. Yeah, I never did look for myself by converting to polar, but I guess there's no reason why it's bad. It's not something that I think to do, I guess. Either way, you still rationalize it. Is the easiest way. Oh God. I don't think I ever did existence and uniqueness for differential equations. Oh God, and they're talking about partials? Man, they have A through I possible answers? That's just mean. Whoa. The second half of the alphabet too? Yeah. just make it like a text box for the response. Let the student type it in. I guess it's harder to grade, but I don't know existence and uniqueness though, unfortunately. So I'm just gonna move on. Well, it's the existence and uniqueness theorem, Penn Center. No, I don't. I feel like I never had to actually apply it. I was maybe taught it in differential equation. Uniqueness theorem. Differential equations. Okay, got an open rectangle for your domain, basically. Hey, monkey. So existence theorem. If f is a continuous function in an open rectangle, oh shoot, you know what? I caught the end of the podcast last night, but I still need to go through and actually watch the beginning of it. What I did here was pretty interesting to listen to, though. It's one solution and some... If f is a continuous function in an open rectangle, well, is f the solution, or is it the... Oh, I misread that at first. I was like, wait, you came on your Spotify? But no, Achy Breaky Heart came on your Spotify. That song's a throwback. Okay, so f is just whatever y prime is equal to. So if that function is continuous in the open rectangle, has some subinterval, so if this function is continuous over the interval, then there's a solution exists. That seems interesting. That doesn't have to be differentiable. Or I don't know. What's uniqueness? You've only seen the version of the Picard-Lindelof theorem. Fancy O? What's fancy O? Like the Greek letter? Oh, that fancy O. Is that an umlaut? Not the, yeah, that looks like an umlaut, not the little U. There's like codes. So if you hold Alt 0246 on the numpad, you can make it. What the heck? It's like your computer's entering the matrix or something with all those symbols. Let me look at it as you're stating it, SPQ. I'll even do the umlaut, though. You have to do it on the numpad, SPQ. If you weren't already. Oh, okay. Well, you have to do umlauts however you're doing them before, I guess. That's like, reminds me of the Monty Python thing. A moose ate my sister once, or bit my sister. And he started putting the umlauts over like every vowel. Hey, Matt Gamma. How's it going? Hello. Yeah, that's what we've been learning on the stream. Just how the alt codes on the keyboard in typing O's with umlauts. It's Windows only. Okay, that makes sense. There might be equivalent on Mac and in Linux, but I don't know them. I'm doing good too. Thanks for asking. Hello. Okay, this explanation is much simpler for me to understand at least. I don't know why I'm even looking at this. Like, I wouldn't feel confident answering this person's question anyway. Um, God, I got my stick. Something evil just started happening in my stomach right now. And I was thinking about ending the stream anyway, so I think before something explodes out of me, I might want to just end stream. I don't know. I just suddenly have a feeling. So I think I'm gonna wrap things up. Let me see if there's maybe someone who's on that we can say hi to. Now that I see who's doing math at least, so I think I'm just gonna call things because yeah, I just suddenly not started feeling too great. If you're new here, welcome in. Sorry that said some people will hop in chat and I'm ending the stream, but I've been going for nearly 4 hours. Want to do a general there's been a good amount of new people here today, so just a general shout out to other math streamers who I know well and can recommend. Yeah, so sorry to kind of end things abruptly, but yeah, I think I need to go deal with whatever's happening inside me right now. So if you're here on YouTube, thank you to you too. And anyone who's been chatting or lurking, I appreciate you all. I'll be back. My next scheduled stream is on Tuesday to do math. I might sneak one in for DayZ tomorrow or Monday. I'm not sure yet though. But I'll be back on Tuesday with math. Also, check out Zach's real analysis class for anyone who's new. It's a really exciting thing. But yeah, thanks so much everyone who's been hanging out. And I'll be back another day. So, all right. Bye, everyone.